to show you some websites which are built using Angular and they are still in use in 2023. So these websites include the popular and very famous names like Microsoft Office, Deutsche Bank, Mixer, Santander, Gmail, Forbes, Upwork, PayPal, Samsung, Delta, Overleaf. So these are very popular names, right? And they use Angular as a technology stack for building their application. So the question which was coming to my mind, that how come these sites they are developed in Angular, and if you see the scale of these applications, these sites, they have lot of users, they have users in the millions. So how come these sites are serving so many users, and how it is managing to be too lightweight, and it's managed to be very less in size and also be a very quick in a response. So we are going to understand the important concept which is behind this reason. There is very important concept which allows Angular application to be very quick and very performant, and that is very essential if you are keen to learn the Angular framework, and that concept is lazy loading. So lazy loading is a very important concept. As I'm saying, in Angular it allows you to make your application very performant, as I was showing you the examples, like the many famous examples what we have, and they have many users, and when you have your application running in a production, you want it to be very quick, very fast, and you want to make its design very tolerant to any load that it can have. So it should basically be capable enough to take that load, and it should allow. Before I start to explain this concept, it is important for you to understand, and let me explain you this. There is a difference between retrieving the application code and loading the application. So basically in Angular there is a difference between retrieving the sources from server host, from the host server, whatever you call it, and rendering or loading it. So retrieving the code means downloading the sources, the files, the assets, the media, whatever required in order to run a web application into a browser. That process is called as retrieving. Loading or rendering, here we are referring web page is loaded in a browser and your users start to use it. There is some interactivity available to a user through your web page. That's what we are referring to a loading. So first we'll try to understand what does exactly lazy loading means. So lazy loading is a design pattern. First thing to notice, there are many design patterns. This is the question that most of the time get asked in the interview, that what are the design patterns that you know. So it's a similar like design patterns that we have a conventionally like solid design pattern, do not repeat yourself design pattern. Similarly, or we have also a dependency injection, which is a design pattern that is also part of Angular. So like those example, lazy loading is a design pattern and it is used to defer the initialization of modules until they are needed. So it means that it allows us to defer the modules of our web application to allow us that whenever we are not using them, we can keep them aside, and we can only get them in a picture when we want to use them. So that's a fundamental concept behind it. It allows us to defer that initialization of modules. We don't want to initialize them if we are not using. If they are out of picture, they are still part of my application, but they are not still in my interactivity till now. So I don't want to initialize them. So that's a fundamental concept behind the lazy loading. It is a great strategy to reduce the time to interactivity of a single page application and thereby provide a better user experience. Now this is very important metric. What we are talking here is a time to interactivity. So if you don't know, time to interactivity is a metric which was developed by Google, and it helps us to measure the amount of time between the point at which the page elements have been loaded and the point at which those elements become interactive. For example, I have an application where I have a profile section and I have a help section. So if I have not gone to a help section, that means I have not made the help section interactive till now. So the difference between a first point where my help and profile page both are loaded and a point where I have clicked on the help page and help page is loaded. The difference between those 2 points, first is your initialization point and the point where I have clicked on particular feature, particular page, and I have went there. So the difference between these 2 times is called as time to interactivity. And since you know Angular is a single page application, we have to make our user experience very fast, because at the end it's everything that is packed in a single JavaScript file, and that is been rendered in your browser. We'll try to see how it works. When user navigates to a web page that implements a lazy loading, a request is made to the host server and all of the packets or chunks are sent to the response and stored in a browser cache. Lazy loaded modules are included in that cache itself. So there are two things we are talking here. First is host server and the second is a browser cache. So when at a first time when application is loaded, it picks all the resources that it needs in order to render the files. Resources I'm referring to a style.css or main.js file or any other assets that are part of your application. So your web client, here it is browser, it requests all those resources to a host server. In our case, a host server is Angular's development server that we usually run on the 4200 port. So it requests all those chunk of data and host server gives it to the browser. Now it doesn't mean that all the data that is received from the host has to be rendered in a single go in a current active window or current active UI what is there in the browser. So that means there is a scope for having some browser cache, and that's where lazy loaded modules comes into a picture. So browser has its own cache, and to have those data which it has received from the host and that is not currently being used in a browser decides that I can keep it into my cache. Now browser need to note that how and which modules or which data I can cache and which data I can instantly show on the UI in the first. So in order to browser cache to decide which data to cache or which not, it need to have some information, and that information basically we are putting in the form of lazy loaded flag. So when we tell that we want to make any module lazy loaded, then browser knows that okay, it's lazy loaded, it's okay for me to cache it, it's not currently active on the window, and I can keep it in my cache. Then with this exception of the lazy loaded module, the packets are assembled, pass, loaded, and rendering the page. So it basically are these next sequence of action that if you have kept your particular module in your browser cache, then the next step of action that browser decides depending on this information browser have that whether to put it in the exception list and the packets which are assembled, pass, and loaded, whether to render it or not. So that's a sequence of action that browser has to decide depending on whether it's lazy loaded or not. When lazy loaded content is needed to render the page, the browser makes a request to a browser cache for the necessary modules to load it. So when lazy loaded content, any particular content on the UI that is needed, then this time request is go to browser cache. Remember that it doesn't go to a host server now. Host server, everything what was required from the host server, browser has fetched that, it has put it into its own memory. Some content of it has put in a cache and some it has instantly render. But now it's up to browser that it has to decide if a lazy loaded content is needed, whether to route that request to host server or to pick it from the browser cache. It happens in usually in the REST API scenario. If you have some particular data that you need and browser doesn't find that data in its local memory, then it asks for the host server. Similar kind of mechanism you have, it's just an analogy that I'm giving of the REST APIs, where REST APIs you can take it from the host server, but here it's not a REST API. It's important to understand it's just an static content, static sources that browser has downloaded and some of it has put into a cache. So basically in the third point, what I'm trying to say is it's a decision of the browser that it makes depending on the flag it has for the lazy loaded module, whether to take it from browser cache or not. Now we'll see how to implement it, and there is no better way to see it in action. So let's jump to the VS Code. So I have a very simple example here in my VS Code where I have three sections. Currently I have a profile, product. I want to show the pages for those, and there is one module I created which is core module, and inside that I have a home and nav. So currently this application what I have set up here is lazy, it is not supporting a lazy loaded, it's a eager loaded application. So I want to show you in my browser that this is my application. Is I have home, product, and profile, and if I just refresh this, you can see I have the JS files which are my applications artifacts which are generated, and you can see that everything is loaded in a single go. So the profile, you can see there's a profile slash profile is my route which was a default route. By default I wanted to come to a profile, and if I click on home, it says that I am on a home page, I'm on a products, I'm on a profile, and if I refresh, I am again on the profile because slash profile is my default path of route. And whenever I'm doing this action, you can see that there is nothing change happening in my network tab. It's just one image that was required, which was just loaded. But apart from that, I don't see any new network call happening in my browser. So that means that all the code which my application need for the home, for the product, and for the profile, all of those code it has already fetched from a host server, which is running here in my terminal, and it is hosted on the 4300 port. And whenever I'm just clicking on those navigation, it just rendering that code automatically behind the scene. And I can see that if I go to elements, what I can see that there will be a change in my app root. You can see that there is a small highlight effect happening, so that just like change in my DOM tree happening. But here I'm not like taking an entire code from the host server or from any local memory of browser and rendering it again. So this is what we refer to as eagerly loaded modules. All of these things you can see that are already present here. If I expand the app root, I can see that I have a app products there. If I click on home, I have app home also there, and app profile similarly. So all those things are already present here. It just like DOM is injecting them at some time whenever the navigation is happened, and DOM is also removing them if they are not currently being used. Now we will try to make this application from eagerly loaded to a lazy loaded, and I want to make a few components of it. Not a few components, all the components that I have here. I want to make home products profile from eagerly loaded to a lazy loaded, so that when only user will click on a particular button, when the navigation will be triggered, at that time only I want to take a code from a browser cache and I want to render here. And this time you will see that there will be some change in our network log as well. So I am here in my app routing modules file. This is a root level routing module file. Every app which we have initialized, it has this routing module, and this basically is a first file for the route. And basically when Angular application checks for any navigation, it start to do that check from this file. So this is a file which is checked by Angular's renderer engine, which is EV. It checks that which navigation it has received and which file to look for its respective route. So you can see currently in a eagerly loaded code, if path is profile and if path is product, then I'm redirecting the request to its respective component. And this is how like conventionally eagerly loaded mechanism is happening. So now in order to enable the lazy loading, I need to make this change here, and that change is we need to add load children property to it. So what I'm telling here, instead of component, I will add a load children in both of the routes, and I will remove the component property from it. Now with this code, I'm telling Angular that if path is profile, then load the children's from this file, namely profile module and the product module. And you can see that this is the mechanism how router modules or how Angular provides us a capability of doing an routing. We have routing modules, and then in the for root method we have to inject the routes array. So this routes array ultimately gets converted to a JavaScript code. So in nutshell, what change we did, we added a load children property, and to load children we are defining which modules to look for if this particular path is this. Remember, we still have not made the decision that which component to render. It's that only we are saying if this is a path, you have to pass this responsibility of deciding which component to render to this module here, which is profile modules, or it is a product module. So now we'll go to a product module, and in the product module there the path is empty. So the reason behind path being empty, that under product we don't have any sub childrens or any sub components. So for example, if under products, if I would have a category, like I have a education products, if I have a entertainment products, if I have a sports related products, if I have a beauty and cosmetics products, if I have stationery related products, if I have electronics and gadgets related product. So if I had that kind of a requirement, I wanted to segregate again depending on what category I want to navigate or want to have a functionality where user can drill down to a specific category of products. So I don't have that. If I would have that, I would have put path slash, and I would have maintain a separate array here where I would decide depending on which path is given. For example, electronic gadgets, beauty and cosmetics, books and stationery, like that, I would decide which component to render. What happened here is through app routing module, Angular knows that profile path is given in a browser URL. For that, it has to go and check the profile modules, or if path is product, it has to go to a product module and check what is the routing there. So then the control reaches here in the product module or the profile module. We'll talk about the product module for this sake. And in the product module, it checks what is the routing module here. So you can see that in the imports we have added the product routing module. So from the product module, the control went to a product routing module, and there it finds a data that for a path, what is the exact component that Angular needs to render. So in this case, we just have an empty path. So it decided that product component is the one that Angular need to render ultimately. And then finally, it checks the products view, which is HTML file, and then it start to take its content, the HTML content, CSS, whatever, and it start to render it on a web page. Similar is a case with a profile module. I don't think I have to explain this thing again because it's the same code that I have here. It's just a small change in the component. Instead of product component, I have a profile component that I am passing in the property component when the path is empty. Remember, this is important because in a real world scenario, you don't gonna have this very simple example. You're gonna have multiple levels of path, and that time you can use that through having a separate maintainable routes array, and through that you can specify which component to render under the profile component. So now if I go to a browser and my application is running there, as we have configured profile is the default page that has loaded, and let me do a refresh again, and you can see that when I have refresh the profile, by default I have that sources for the profile downloaded, and my regular files that were there already. Now I see there is a one more request which is for the JS file 482 that is now loaded here, and that's something different I see here, and we'll see what is the purpose of it and what's exactly it represent. Main difference now is if I click on the products, you can see that there is one new request which happened, and if you see the status code is 304, which means it is not modified since last it has received. That means browser has cached it. So if you Google it, you will find that 304 is a status code where your application gets the data from browser's cache. So that is the part which I was talking in earlier minutes of this video, that response Angular application received from the host server, it stored that in the browser cache. So you can see that lazy loaded modules are included in a cache, and this is a proof of that. With this application, we have demonstrated that when I see a status code 304, it means it has cached, and the content which I need for my lazy loaded modules, that is being picked from 304. Unlike of this, you can see for this data is which has loaded from the host server, and that's why the status code is 200. Now if I click on profile again, I don't have any change here because it's already loaded, and renderer don't have to load it from the browser's cache. If that is already loaded in your application, it doesn't make any new request to a browser's cache. In a nutshell, again I would like to repeat this. If your modules are lazy loaded, they will be rendered into your browser when they becomes usable, when they comes into an interactive window. Until then they are not loaded. So with that, Angular application saves the operation, saves the computation that are required to render or to change the DOM tree, and that's where lazy loading helps to achieve the performance. It saves the time. So coming to a conclusion, I can say that lazy loading is one way for the developers to decrease the time to interactivity. As I was talking about, time to interactivity is a difference between a point at which application is retrieved and a point at which the application or particular module has been loaded. So this reducing this time, basically it improves the user experience and it reduces the bounce rate for the application. So application don't want to go to server, host server again and again and take the same data over the some period of time again over the network, over the HTTP request, because that is adding a cost in terms of computation, in cost of performance. Lazy loading does not decrease the overall size of the app. It's very important to know that lazy loading doesn't help you to decrease the overall size of the application. The artifacts that you have generated for your application, they are going to be same in size. Usually they are around 1 to 2 MB, and Angular application doesn't exist like more than few MBs. It's always 4-5 MBs if your application is more complex, but it doesn't exceed more than a few MBs. Even I would say any application which is greater than 5 MBs, it's not properly coded. Let it be any complex application. Angular application has to be very less in size. I'm talking about the artifacts which are generated, which are downloaded in your browsers, like these files, main.js, polyfills, runtime style JS, and the style CSS. Those are always less than 5 MBs. Doesn't matter how complex your application is. And the reason behind that is that any front-end application that has to load it very quickly, if you see some statistics from the Google, it says that user tend to move away from the site which takes more than 3 seconds to load, and that means it's very crucial for any application to load instantly. And there are tools like Chrome Lighthouse which allows you to monitor these parameters, and it tells you how much is your score in terms of page size, your page loading, your entire application bundle size. So have it in mind. Retrieving a code from server and rendering it on a browser, these are the two different steps, these are the two different processes, and it both has its own sub things involved in it, and it both has its own mechanisms involved in retrieving it. Just a download operation over HTTP, while your rendering, it has some computations into it, where your Angular's render comes into picture. You have to do a parsing of the data that has been received, and you have to form an HTML code at a runtime. So their lazy loaded modules are not loaded initially. That's the difference. When they are needed, browser makes a request to the browser cache, and that's where we see the status code 304. It is not to the host server. Lazy loaded module sits in the browser's cache, and they are picked from there and now passed to a renderer where they are shown on a web page. That's it for this video, and I hope you find this concept useful. Thank you.